Welcome everybody. We will start by playing a game that Shreya is going to guide you through.
Hi everyone. So this is a quick game to start off, kickstart your brain. It's a 5-letter word which you have to guess. Just guess letters, and it forms a word. So we can get started. A 5-letter word.
Rates.
Sorry?
Rates.
Okay.
R-A-T-E-S.
Okay. So the letter E is the correct letter and it's in the right position.
It's an English word. English word.
Oh, okay. Okay, so D, the letter D is not in the right position, but the D exists. Yes.
First game done. This is a great way to kick off a class. It brings us in the middle of things. Of course, you could continue discussing information entropy and stuff like that, but we've never done that so far. And let's kick off the presentation. How do we get into presentation mode on this?
Top right, the left. Top right, the left button. All the way in the top right. Further up. Und da das linke.
This. Wow, awesome. So this workshop is titled Probably Fun. We are Kristian and Shreyaasri. So I've been around as a freelance Python trainer since 2009. I think the first time I was speaking in this building was in 2014. And I'm based in Berlin.
Yes, so a quick introduction about myself. I'm Shreya, and I'm currently wrapping up my master thesis, and would be joining Kristian as an assistant professor to teach the AI course at the university later this year. So that's about myself.
How do we came to do this? I have a big passion that is board gaming. Yeah, among popular board games that I play is Ark Nova and Terraforming Mars. Does anyone in the room know any of these? Yeah, awesome. There's some. These are great, but they have a big disadvantages. They take 2+ hours to play. That means they are not really suitable for classroom work on machine learning. Yeah, but this gives an idea, and it turned out that we are not the only persons who have thought about this, because board games are actually approved by UNESCO as an immaterial cultural heritage. Yeah, so, and you can do a certification in Germany as a Fachkraft of Gesellschaftsspiele. 2 years ago, I had the choice to sign up for Kubernetes course or to do the board game certification. I went for the board game certification because I thought it's more fun. Yeah. And there we picked up ideas how to bring gaming into the classroom. Why? Because games, they contain tons of data science, mathematics, geometry, statistics, all of those. The moment you touch a dice, the moment you draw cards, you have data science in your hands. And ever since then, Shreya witnessed quite a lot of this in different courses. We've been experimenting with using games in the classroom, like it starts with having quartet cards with numbers on them. You can make plots out of these and pivots and stuff. We had a dice baking session and then doing a chi-square test to see if you roll more 6s. I found a lovely game where I said, oh, look, there's a binomial distribution on the board, and there's lots and lots and more things that you can do. We did a similar tutorial together with Paula Gonzalez at the PyCon DE in spring in Darmstadt. Was anyone there in anyone of the room? Laura was there. Two of you, okay. Here we put a bit more focus on the machine learning side. So we brought a few different games, but we also brought the evergreens for the later third of the thing. So what we want to do is we want to give everybody who is in a potential teaching situation, that also includes some parts of company work where the function of a senior is often getting the less experienced people on board and make them learn faster, to give you some ideas that you can easily integrate into the practice, whether you are a full-time, do we have any full-time teachers, education persons here in the room? No, who does a bit of education as part of their job? Some who is generally interested in speaking and learning and helping people to learn. Some, okay. Oh, and I think the rest just wants to play. Okay, I see. So what we do is we have like 3 specific families of models that we want to address by games. We have then something that brings together stuff from different buckets. We have a Q&A session, and depending on how time goes, we make a game rotation where you can try out different stuff until people kick us out for lunch. Yeah, so it's going to be a soft ending. This is why we have the vertical spacing there. Good, with that, I think, Shreya, are we ready for our next game?
Yeah.
So let's do the decision tree.
Yes. So I have an animal in my mind. So you'll have to try and guess what it is, but you'll have 10 tries, 10 attempts. And then maybe I would give a hint, a bag of words. Okay, let's start. Nope.
Shreya is only answering yes or no. Is it mammal?
Nope.
Is it a reptile?
Nope.
Is it a bird?
Mm-hmm.
Repeat the questions for the recording.
Okay.
So it's a bird.
Not really. It does? Yeah. No. No. Sorry? That's a lot. No.
Is it a penguin?
No.
Does it eat meat or fish?
Don't know.
Yeah.
Do we have more questions? Yeah, keep asking.
Is there a library named after the animal?
No.
Is there no writing book on which it is pictured?
Yeah.
Did that help? And there's millions of variety books with birds.
Does it have very long legs?
Yep. Yes, that's the right guess.
So you got the idea how you guess an animal. How is this model called? It's a decision tree. Good. Now we want you to make your own decision tree. Yeah, we prepared a worksheet. This is an offline exercise. If anyone is listening online, I will point them where they can find the worksheet, because we have that available on a copy. I'll put the address on the screen for you. So what we are going to give you is a worksheet with a little decision tree and a where you need to fill in questions so that the animals get predicted. There is a sample of 4 animals. This shouldn't be too hard. You should be done in 5 minutes with this. One of us is smiling. You've been there before. I think you know the thing. Yeah, and then we see how well the decision tree works. Let's share the stuff. We brought some pens because you're IT persons. I didn't know whether you will have anything to write with you. Let's hope this works. So it's 1 sheet per 2 persons. And for the recording, I'll put the address here. You find a worksheet like this. So write some questions in the boxes, write the predicted animals from the top into the square boxes. Muss man das anschaffen? Ist immer. Okay, super, danke. Ja.
You know, and another thing that we could like add for all Python conferences, I saw in the text the architecture of event, so they don't have these methods. So they put this red queue inside so that it doesn't go off. Okay. Or do I?
1 minute until we put your models in production. So the tree should predict the 4 animals that are in the top right of the sheet. I hope I did not mess this up completely. Let's see what we get.
Yeah. Oh, I think they're done.
I think they are. Let's ring the bell. Okay. So, we have models. Great. Now we need to test them. Yeah, for testing, you need test data. This is not an entirely clean experiment because some of the test data was visible on the screen before. What is happening here? This is not our computer, sorry. Öffnen mit. This one worked before. Okay. So what we would like to do is you take the animal that is on the picture, run it through your decision tree, and put down in the table what is being predicted. Yeah, that might be a crocodile. If somebody wrote reptile or something, it's also fine. Yeah, we can be a bit generous here. Yeah? If you did not have a crocodile in the training sample, yeah, then there should not be crocodile coming out at the end, right? But something else, hamster or whatever you had. Good. Okay, I think that's clear. Laura? Look on the top right of the sheet. There are 4 animals. They should go into the square boxes.
For the pair prediction, do we just call like 3 volunteers?
It's 3 pairs, ideally. 3 pairs, because they need to work together.
Oh, yeah.
Okay, question. Who has, quick show of hand, who is actually predicting crocodile? Okay, who is predicting something else? It's a lot less, so crocodile is apparently by far the most highest ranking prediction here. Let's try the next, the giraffe. Okay. So, question, whose model is predicting giraffe? A few less, which models are predicting something else? It's close to a tie, but I think we saw a few more giraffes here. Let's take the next one. This is a python. If anyone wrote snake in the box, anaconda might also work, but it's definitely a python for obvious reasons. Okay. Show of hands, whose decision tree is predicting snake? I think that's a majority. Do we have other, what other, does anyone have a different prediction? No, less, okay. Test data point 4, shark. Fish is also okay. We don't have any other fishes in the training and or test set. Somebody predicts a snake because your decision tree never saw a shark before. Okay, it's fine. Who is predicting shark? Yeah, it's okay. That's a sufficient number. Awesome. And this is a gentle reminder that in real world the data often looks a little bit different than when you train. Yeah. How are they predicting shark? Because they have a shark in the training sample. Yeah, you don't have a shark. Who is predicting mouse? If your question was, does it have 4 legs? This one won't work. Yeah, Anyone predicting mouse for this one? Yeah, anyone predict giraffe or shark? Then did anyone, what did you predict this as? What, a penguin? This is a penguin. It's close enough, yeah, close enough. So it doesn't have to work perfectly. Yeah, there's the actual penguin. Try that one. Who gets this predicted as a penguin? Oh yeah, penguins are easy to predict. Awesome. This is why I like this data set a lot. Okay. Folks, what did we just do? What did we train? A random forest. We trained a ton of decision trees on different training samples, put their predictions together, and the result is somehow better than each individual tree, even if none of the individual trees does see all of the data points. I think we can switch to the original presentation. Where is it? No. If I go back here. Ah, yeah. Thank you. So this is actually a random forest. And this is a nice example. This is actually one of the things how you can approach teaching. We trained a random forest, got the basic building principles across. We reduced it quite a bit without touching a single line of code, without getting distracted by the technical detail. And all of this, and you can easily follow this up with code, with theory, with introducing the Gini formula, whatever you like. Yeah, and it doesn't take too long.
Yep.
Should we do another game?
Yes.
Let's look at language models. Does this one work? Oh, okay. Shreya, could you operate the slides? Not yet, because I need to ask them a question. Now we want to try something with language, because languages are an important type of model, and we would like to start with one of the simplest language models possible, that is the bag of words. So we take a text document, chop it into pieces, we tokenize it, and then we make a prediction. And we would like you to predict which text document it is, right? Based on that bag of words. Good. Now, which text document is it? No slide switch yet. No. Ah. Did anyone see it? No. Good, which text document are we predicting? Zen of Python. If you don't know anything yet, and you guess Zen of Python, then you have a good prior probability. Yeah? So you can literally explain that concept without anything. Shreya, let's see the Zen of Python. So that's the bag of words, that's all the words. The order is completely messed up, and that's all we have. Yeah. So, how could we improve that model or that type of prediction? What could we do, Laura? We could change the size of the words based on frequency. Shreya, let's see the next one. So, which text document is this? It's the first time we are doing this. We are not sure whether this is going to work. We have hints if you get stuck. Think about it. What type of text might this be? It's a song. It's song lyrics. Awesome. It's song lyrics. Shine Bright Like a Diamond by Rihanna. Awesome, awesome. Took a while, yeah, but it's working. Yeah, yeah, of course, the diamond is your target variable. You are trying to predict that. So I took all the words out that are in the answer. Yeah? Otherwise, it would be too easy. Yeah. Now, we see that there's a lot of words floating around that don't have very much information. Okay, like A might have a bit of information here, but for the other examples, let's kick those out. What is this called? Stop words. Shreya, let's see the next one. There's the stop words kicked out. It's again a song. I will survive, Gloria Gaynor. Awesome, well done. Yeah, good. There's more NLP tricks that you can do on this to reduce your language space. Look at this, we have loving here, and I think there also should be love somewhere. I don't see it. Oh, it's a big one. It's basically the same word. What can we do to put both of them together? Stemming or lemmatization, I never know which is which. We have a lemmatized song. Let's see the next one, okay. It's fewer words. We are reducing and reducing our feature space. Gets overfitting out of the way. I think this was written before almost all of us were born. I Have a Dream by ABBA. No, it's not. I think it's a bit older even. It's from a British author. Yesterday by Paul McCartney and the Beatles. That's the one. Good. Are there any other things that we could throw on this to reduce our feature space or might make our features more significant? We can do something like that. We removed already the stop words. Now we could also de-rank like very common words that like every song has. Like if you have love in a song, that doesn't give a lot of information, but sometimes you find songs that are very unique for a given song. Expressed in math, that would be the TF-IDF score that upranks you words that are very characteristic for a certain for a certain song. Shreya, let's see the last example. Which one, sorry? Bohemian Rhapsody by Queen. We predict that from a single feature. Isn't that great? Yeah. That's the bag of words. Thank you. So the Wordle and the Wordle doesn't really require any preparation. This one at least had to some work to generate the word clouds, and think hard about what documents your audience might know. That is easier if your audience is bigger. Yeah, so that if you have a class that is working on some text anyway, or some documents that the team knows, yeah, then it gets easier, but it doesn't take long. Yeah, and also a easy way to simulate something without getting lost in the details of math and algorithms. Good, Shreya. What do you think what we should do next?
The next game?
The small language model. Yeah, we need volunteers for this one.
3 pairs of volunteers on stage, please.
Maybe we should explain what the volunteers are to do.
Okay. So every pair would be given a word, and they have to explain it to the other person what it would mean, but don't say the word.
They explain it to the entire audience. Okay. And the audience, again, has to guess which word it is. But you take turns saying a word. One word. It's the same word for a pair of volunteers. So you explain one word together, but it's Like I say one word, you say one word, I say one word, you say one word. Yeah, Laura and Andy, awesome. Can we have some applause? This is very brave. So, you understood the rules? No, let's explain again.
My wife understands, that's good.
So you both know which word we are trying to predict. No, they are trying to predict, but they don't know. Okay? So one of you starts, let's say Andy, because he has the microphone. Andy, you say a word. Laura says another word, so that what you do actually makes a sentence.
Oh, okay, I understand.
Yeah? Laura, here's your microphone.
Okay.
Okay. And so we want to make a sentence together. Yeah. Okay. Okay.
Oh, I understand.
You want to start?
Black.
Animal.
White. Oh, it has to make a sentence.
Yeah.
Black animal with
A.
white.
Toe beans.
No, that's not a sentence.
What do we say? White animal with a black. No, black
animal with a white.
Face.
And yeah, there we go. Yes. Okay.
I think we need another pair of volunteers for the second word. What? We have one? Two. Oh, two. Applause, please.
That what's your?
Yeah,
Animal
that
is
very.
long.
You said it. Python. Yeah, nice.
And who's in for round 3?
Quack. That's not a word. We should make a sentence. You said quack. Yeah, okay, quack.
Quack
Is
the
sound
that
that this. I mean, we already had that. Or, yeah.
software
Animal.
DuckDB. Awesome. So,
Could we please have the last round? Another pair of. Yep.
we have a last round. Maris, great. And Alina, please.
You.
Use.
It.
To.
Train.
AI. Model.
So I found this small language model game actually in a group of teachers who do this as an exercise to repeat all kind of stuff. Yeah, so this is not specifically tied to the data science domain. It works on everything, but we have, of course, here this aspect of predicting the next word, going internally while you are doing this, going through a list of candidate words, taking the one that probably predicts is the best predictor to help others guess the word successfully, and then the stuff that small and large language models do when they predict the next token, including the softmax function. This is just around the corner. So I labeled this a priming exercise because that's the word the teachers use when you want to, how would you term that, Shreya, when you want to warm up the brain for some specific area or task. That is what the small language model does. Good. We have another game with questions for you. Shreya, we have 5 questions. Can you go to the next one? We will ask you a question. Find question 1, please. And this one is a bit more tricky because we want you to predict what is the answer that most people in the audience will give. Okay? And then you count how many times you guessed correctly. So please, when you have to make up your mind what you want to answer. When you are done, please do this. Okay? Shreya, what's our first question?
Yes. The most favorite food in the room. The most favorite food in the room.
Let's wait for a few more of these. So let's see, what do we have?
Pizza.
Pizza. Who has pizza? Oh, I think that's the overwhelming majority. If you guessed pizza, you have 1 point. Question 2, please. Yes, question. No, that is the same thing. So you guess what the majority of the others would say, and that is your answer.
But what they say to the question, what is the most common answer, or to the question,
Yeah.
what is the true answer?
No, this is self-reflective. There's a recursive condition in here. Yeah, this is difficult. Yeah, but I guess you are software developers. You'll figure that out. So your most predicted most common answer is depending on what the others think is the most common answer. Yeah? This is why it's called wisdom of the crowd.
Okay, the second question, most popular sports of participants. Sports. Sports.
Actually practicing yourself. Tough one. Let's hear some ideas. Football. Bouldering. Can we have the third one?
Cycling.
Cycling and football. Who has football? That gets tougher. That's some football, soccer is the same thing, okay? Around here. And some 15 people maybe. Then we had cycling. Definitely fewer. Bouldering. And what was the last one? Already. Running. Anyone with running? I think that's less than football. Yeah. So if you guessed football, then you have a point. Question 3.
The most favorite programming language. The most favorite programming language.
I guess Python.
Anyone else with Python? That seems to be easy. Anyone who has 3 points already? Wow. Do we have a question 4?
4 and 5.
Okay, let's take this one.
The most popular song.
Yes, you are primed. That is, we have a bias in the room. And now you're biased even more. Oh, that's how easy it is to bias results. Go ahead, ask a few people.
Galileo.
Anyone else with Bohemian Rhapsody? Okay, some 6, 7. We have other candidates.
Yesterday.
Anyone with Yesterday? Fewer.
Shine bright like a diamond.
Shine bright like a diamond. Anyone else? It's a very close call. I think Bohemian Rhapsody was ahead a bit. We have a last question for this. Anyone with 4 points here? Okay, 3 people. Ooh, yeah.
Okay, the last question. Average train delay in Germany.
In minutes. What is the average train delay in Germany in minutes? Only Deutsche Bahn. Because Marco Gorelli primed me for that. A train that doesn't arrive is not a delayed train, according to Deutsche Bahn. So if it fails completely, then it doesn't count to the statistics. That's very convenient.
I think I would go that side.
30 minutes.
30 minutes? Anyone else with 30 minutes? Wow. Okay, what other answers do we have?
120.
1 hour, 20 minutes? It's 2 people. It's not that bad, actually, I hope. Yeah.
20 minutes.
20 minutes? Anyone with 20 minutes? A few? What else do we have?
I had 20 minutes as well.
Oh, okay.
I had 60 minutes.
60.
60, yeah.
60. Anyone with 60 minutes? We are talking about an average. Okay. Do we have other candidates? 15. Anyone with 15? I didn't count precisely. Shreya, do you have an overview which one we had more of? Was it 2 hours or 15 minutes?
No. Yeah.
30. 30 might have come on top. 20. Can we again see 30 and 20? 30? Yeah, and 20? Yeah, I think 30 had a few votes more. So 30 it is. Good. Awesome. So do we now know the average train delay in Germany or what? No. Is this a good method for finding out the truth? No, it's not. What are we doing here? We are reading the room. If you were an AI model, what would you be doing right now? Sorry again, is? Giving wrong answers that sound convincing. You're hallucinating. That's how easy it is. Yeah. So if all we ask you is to predict the next word, the next sentence, it's damn easy to hallucinate. Nice way to illustrate a concept. Good. So we have. Sometimes it's quite challenging to come up with a useful game for a particular model. For instance, we haven't really come up with anything that directly simulates something like a support vector machine, or even with linear regression, it's a bit of a challenge to incorporate the maths in a game. But we have a different method that you can use in place.
So there will be another round where we'll be distributing the papers, and then we need, you guys are supposed to form a team of 4 to 5 people and try and take the quiz within a certain amount of time.
Again, if anyone is here online and wants to see the thing and try for themselves, I'll guide you to the correct spot. This is how the PDF looks like. You find the URL on top. Under no circumstances use phones or computers or other electronic equipment to find the answer. Yeah? If you want, you can take the papers apart and distribute it to do parallel computation. That's up to you. Yeah? We'll take a look on the clock, and after 15 minutes, we will stop the whole thing and see what answers we can find. Let's go. Okay, good. Yeah.
Okay.
So
this would be the last part.
yeah, then we do a Q&A. When did we start? At 10:40.
Mm-hmm.
So that means this runs until 11:40-ish.
Mm-hmm.
Then we go through the answers.
Okay.
We do Q&A, so that means we stop around. We are done with around 12 with that.
Okay.
That's perfect.
Yeah.
When any team is done, please wave so that we know how you are doing. Okay, time's up. Now, please take the sheets with your answers, put them in a pile, and pass them around in clockwise order to the next team, because they will be tasked with calculating scores for you. Okay. So please pass on your answers to another group. Does every group now have sheets from another team? Yes. Yeah, they are still trading. There's a good market for bar quiz answers. Great. Something that was not very obvious because all of you were busy. Yeah. The spot where you want to be in while teaching is your course participants. Then swap, please. Clockwise order. Draw the convex hull. Oh no, it's a convex hull with concave elements. What is that? Also has a name. I don't remember. It's not probably fun algorithmics today. We'll submit that next time. Awesome. So the spot where you want to be in when teaching is all your participants have work to do. They are busy thinking. That is where you want them to be. And you have time to observe and remove obstacles and do what your job as a teacher is. Yeah, that is what this kind of thing helps. We've also played this at parties, yeah, with less data sciencey topic, but you can take it into a classroom easily. Has a bit of overhead because you need to create this once. Yeah, I think you may remember we may have done this many years ago, or maybe not. I don't know. Okay, let's go through the answers. Shreya will do the first few questions, and we are going to ask you to toss in the answers, and please count the score for the other team.
Okay, so let's start with the first question. Let's get the order of all the names. Llama, Gemini, Grok, yep, Claude, DeepSeek, yes.
Question 2. Did anyone find or guess a slope?
Seven.
7.
7 is the right
7
answer.
is correct. If we round 6.5, that I'd let that through.
Yeah. The intercept. The intercept. Sorry?
Can you repeat, please? Minus 3.
Minus 3.
I recall putting that in, yeah.
2 point. Do we let it pass by minus 2.5 to 3?
Rounded.
Yeah.
Rounded, minus 3 rounded. Okay.
The mean absolute error.
Six over 8.
The mean squared error. Answer.
And does anyone have a mean squared error? 10 over 8. 21 over 8. I must admit, I forgot to calculate that one. Yeah, so we don't know. If you have a number, you give the points. Question 3.
Okay, question 3. Do you have any answers?
Sorry again? 0.7.
Yep.
Correct.
That's right. And then question 4. Let's start with the first equation. Does anybody have answers to the first one? Yeah, Bayes' theorem is right. The second one, mean squared error is the right answer. The third one,
which one? The sigmoid function.
Yes.
The third is the sigmoid function.
The last one,
Ridge regression loss.
Yes.
Awesome. Okay. Now the tough part. Permutations. So we have words that are anagrams of other words. Did anyone figure out any of these? The third one, for instance, I think the third one is easy. Naive Bayes, awesome. Naive Bayes. The other ones are machine learning models as well. Naive Bayes, like in Bayes' theorem. Armored fonts. Random forest. Ah. Elsinore earrings. Linear regression. Yes. Yes, that's linear regression. Good, well, good job. Antioch proof spectrum. Support vector machine. And alignment suckers. Alignment suckers. I think this one was nasty for some reason. I think this is K means clustering. Now for something more pleasant. Bugs in the Python code. Let's go through this line by line. The first line. Maris. Has to be a hashtag for a comment. Second line, is there a bug? No. Third line, total equals 0. Is there a bug? Yes. Has to be outside of the loop. File name equal. Any bugs here? Maris. Has to be an F string if you want to insert a variable. What else? Sorry again? No. Backslash Y, what is this has to be a forward slash. It's a path separator. Or a double backslash or an R string, but you cannot use that if you do an F string. Or can you? I don't know. Windows. The second for loop. For line in open. Oh, it has to be read. I missed out that one. I found this. I found this code in my repository of puzzles from 5 years ago, and I didn't see my own bugs. I didn't run this. Okay, so but there has to be an R. Anything else? The colon missing. Yeah. Then next line, columns. The strip and split have to be the other way around. Excellent. What else? Yes, Maris? Double equals has to be a single equal. Okay. Next line, total. Yes? It has to be inside the loop. Which loop? It has to be in the inner loop, definitely. Is there a space in the split? I don't think we need a space in the split. Depends on how the file looks like. This is a comma-separated file. This is how I parsed CSV files for the first 10 years of my Python career because pandas did not exist. Yeah. Plus equal. This is nasty because equal plus is valid Python syntax. Yeah. Black fixes that, by the way. Last line, anything missing there? Parenthesis missing. We don't need an F string if we do dot format. This looks a bit old school these days. Sometimes it's still useful. I think that was more than 10 bugs. Question 7. Sorry again? Oh, damn it. There has to be total. Thank you. Thank you. Missed out that one as well. Good. Awesome. This is what code reviews are good for. Question 7. Person on the top left. Guido van Rossum. Yeah. Shreya is gone. So, no, I can take that one. Sorry. Picture on the top right. Ada Lovelace. Bottom left. Andrew and yeah, I don't know how to pronounce his name either. And this one on the bottom right. Sorry. Geoffrey Hinton. Great. Okay. Question 8. The series of numbers horizontally. I didn't write that, but first row. Fibonacci, that's the Fibonacci series. Great. Then second row. Factorials. Great. And the third one, did anyone figure out the third one? It's not random. It's quite the opposite of random. It's math.e, the constant for the natural logarithm. Nasty one. Do we have a question? We do have a question 9.
9, yeah.
You want to take that?
No.
No. Question 9. Parameters. Which fits to the decision tree? Sorry again? Can you go back to the factorial, please? So we have 0 factorial, which happens to be 1. 1 factorial is 1. 2 factorial is 2. 6 is 1 times 2 times 3. And then the numbers get big very quickly. The first one, I heard it's easy to prove, but I cannot do the proof myself. It's because of the 0. It starts with a 0. Okay? Any objections? No. Good. Then, hyperparameter for a decision tree. Which hyperparameter fits to a decision tree? Maximum depth. Ridge regression has the alpha parameter for the regularization strength. Support vector machine. The kernel, the RBF kernel is the most popular one if you want to do a nonlinear model. Convolutional neural network, kernel size, and multilayer perceptron, that is the activation function. Good. Last question. I like to include a little bit of trivia in this because it's not just tech, it's also culture to some extent. AI systems. Which AI system said, I'll be back? Terminator. I'm sorry, Dave, I'm afraid I can't do that. HAL in Odyssey, what is the English name? Odyssey in Space. Space Odyssey, thank you. I've seen things people wouldn't believe. That's the robot from Blade Runner. Does anyone know his name? I think I saw it. Roy, thank you. Sir, the possibility of successfully navigating an asteroid field. It's not data, it's 3PO, or maybe data has said that as well, but I think he would use a different terminology. Okay, sum up the points, hand them back to the other group when we are done. I'd like to take this. This is the bar quiz. It's a nice way to finish up a longer course. How are we standing time-wise? Perfect.
Yep.
We do a landing on point.
Yeah.
Yep. So, what's next? We have 10 minutes left on the official schedule. We'd like to use this to do a little bit of Q&A. And once we run out of questions, we open the informal part. Yeah, I'll give you a bit of time. My last question is going to ask whether we have a winner. Yeah, if we manage to calculate sums. Okay, but you have seen now a couple of different classroom tools that you could apply in a formal teaching setting, but some of them also work in an informal teaching setting, like when you do some informal cross-training in a company. Not yet, after the Q&A. Good. And we are open for questions.
Do we pass it on the mic?
Yeah. Can you? We have a question over here.
I just wanted to ask if you put the material online somewhere.
The material, yes, thank you for asking. The whole, guys, oh, you have so much energy. This is great. This is great. You're not falling asleep. So all the materials that you have seen here, they are available in a GitHub repository that is called Probably Fun, I think. The QR code, is the QR code working? I put it up this morning. Awesome, it is. Good. Other questions? There's one.
Thank you for the section. I really enjoyed myself. So, what's the real-life application of small language, SLM? So what's the real-life application? Because it's as though we are playing games and having fun. So I would like to know the industrial real-life problems, something like that.
The industrial real-life application that I do on a weekly basis with this kind of stuff is that that it helps to make students learn more easily. Yeah, so because usually people have a limited attention span. Yeah, so you can throw theory at them, and usually that only gets you to a point. Yeah, because the human attention span is limited. People start drifting off. If you focus on the theory, then it's getting boring after some point. Also, you are basically competing with the internet. So there is your job as an educator is not to get all the information out of your mouth, because there's faster channels for that. So your job as an educator is to inspire persons in order to make them want to learn more. And I think starting with something, integrating like these small games into your teaching practice, it makes the learning a lot easier and makes people want to learn more, even when you are out of the room. A not negligible effect of that, it's also taking away fear. Yeah, something that I find has quite one of the biggest variables that influence learning is when people are nervous, when they are stressed, when like, let's say, when you give them as an educator the impression that that you better take care or you will fail, whatever there is to fail, that gets in the way of good learning. Yeah? And that starting with a game helps to make clear that I'm not here to kick you out of the university or wherever you are. I'm basically here to help you find out interesting stuff.
So it's only applicable in just to ease tension. So there is no it's not applicable in. As I said, industrial, what I meant by industrial, like in organizations, yes. Like if you are working with real life data, let me say customer data, production data, and the rest of them, is there any example that would like help you drive home your point, aside from in classroom environment?
Andy, would you like to comment on this? I have a hypothesis. You've been there.
Yeah, no, I was just going to say that one of the things that me and my wife have worked on a lot are making very, very transparent decision systems in various areas. We've named this kind of like Bayes by hand. But to give a very concrete example, there was a statistician named Andrew Gelman who was working on a project to protect children from harm. And they needed to produce an assessment score of the danger that some child was in. but this needed to be understood by caseworkers, by judges, to be very easily explained. So they created a regression model, but then they boiled it down into basically 5 categories, and there was a score from 1 to 5 in each category. And if the total was above some number, then that child had to be removed immediately. And if there was a 5, so most dangerous in any one category. I think the categories were like shelter, safety, physical safety, a few other things. And so there was a very simple rule that they wrote down, and it was statistically backed and backed by data, but very, very easy to explain. So almost like a set of simple rules that would match something like a game like this. So I think being able to turn something very complicated into a set of simple rules that can be easily communicated is extremely valuable in certain areas of industry.
It's the same thing for thank you, Andy. It's the same thing for the random forest. If you are implementing random forest models in production, yeah, of course you need to know the details. You need to know what the Gini score is. You need to you need to handle scikit-learn or whatever you use to train it. But the other stakeholders in the project, they maybe don't. And making them understand what you are doing, this goes a long way. Other questions?
Yeah. Anybody has a question? Oh, yeah. Laura.
I'm just wondering, like, how young do you think people who play these games, like, how young would you go in terms of, like, who would find this stuff accessible? And like, some of the games were sort of discovering concepts, you know, like the bag of words was sort of discovering these concepts, like, by thinking it through, whereas, like, some of them are more like you have to have some base knowledge in order to, like, even tackle, like, looking at the sequence of numbers. If you know maths, you wouldn't really be able to, like, tackle that. So how do you think about who's the right audience for, like, different kinds of games, or, like, what's age appropriate?
I think the games, they all serve a certain purpose. I see basically three types of this. Yeah, something that I termed here priming. This definitely you would find more at the beginning of some session that has an educational purpose, like the bag of words. It skips a lot of detail. Yeah, you cannot do this and then state, hey, this is now you know everything that is necessary. You certainly don't. Yeah, so if you want to do your job properly, you should follow up with something that has more substance, but complements the gaps that the participants now should be aware of. Then there's other things that help with wrapping up lessons, because a lot of teaching has with seeing the same words again and again. Repetition is in much of education an underused tool, in my opinion. So at least in this part of the world. So there's value in that. And then there's some things that you can really use to promote understanding. So something that I regularly do in courses is I throw buggy code at my participants, and there they actually have to use the tools that they need to know to do business. Yeah. So this was an easy example. Yeah, that you can, as people with Python experience, can understand and debug without actually running the code. But I have more complex code examples in my bag that I just didn't bring here because the debugging tutorial that I did at PyData was in 2017, I think. Yeah. So that gamification aspect can also work as the main dish.
Anybody has a question? Don't be shy. Question about didactics, question about the algorithms. Unfortunately, there is no question from online. I checked a couple of times, but yeah, people were either too shy or had problems to follow. But I can only tell the people who are still following online to check out the material, very good material. It's hard to judge, but it was probably hard to follow from online, but definitely check it out. So, one question here, one more, is it okay?
Yeah.
So my question is, in a group setting, like if you're working in groups, how do you deal with an extremely varied knowledge base of the group? So group dynamics of how you would keep everyone engaged and motivated when stuff is like too hard, because you have this flow state of like something that you don't know, and how do you keep that?
So it's generally easier with games. Like when you do things like explaining concepts, you have to find a have to find like a baseline, something that everybody is familiar with. Yeah, you need that in an engineering team as well, by the way. Yeah, so that helps to that. And one purpose of something like that could be to identify the parts where that somebody may find difficult and get the people to talk about it more easily than if I were to go around and ask everybody individually, hey, can you explain me the exact syntax of the I don't know, of the pandas.reset index function? Yeah. Some of you may be able to do that off the cuff, but for some others, this might be quite a scary moment. As a teaching person, you don't want to do that. Yeah. So so I see this also as a tool to find common ground and bring like very diverse audiences together. Okay, thank you.
Any more questions?
Final remarks.
Yeah, thank you, everybody. Yeah, I think this closes the session. Of course, I would have had the question. You have all those games here on the team.
Yeah, we have an aftermath. Yeah. So first of all, I brought my guest book that I usually bring to courses. It's near to the door. If you'd like to leave a signature, I'd be very happy to do so. Yeah. Second, we brought a couple of extra games that revolve around the topic of. It goes a bit more into the statistics and Python domain. If you want to try a game with a group of 3-4 people, stay at your table. We'll get something for you to play because we don't have anything to do until the lunch officially starts. Quick question on the bar quiz. Do we actually have a winner? Can we hear any scorings?
Oh yeah.
44. I hear a 44.
Who has more than 44?
66.
Who has more? More than 66? Okay, then I think.
So 66 for the group in the middle.
Round of applause.
Thank you. So, if you like to play a game, stay seated. Otherwise, thank you very much for attending.
Yeah, thank you.
Thank you, everyone.
Thanks to speakers.